Greetings, chemistry students. Today we're going to talk about what happens when you mix an acid and a base together. And that process is called neutralization, which it gets its name because an acid is obviously acidic and bases are basic. If you mix them together, the solution becomes neutral or approaches a pH of 7. So, neutralization reaction is the reaction between an acid and a base. And if you mix an Arrhenius acid and an Arrhenius base together, your two products are water and a salt. Because if you'll remember, an Arrhenius acid has hydrogen in it, and an Arrhenius base has hydroxide. Well, the hydrogen and the hydroxide combine to form water, and then the two other ions that are left together form the salt. And we've seen this definition before, but a salt is any ionic compound that's not an acid or a base. So let me show you an example. If we have potassium hydroxide reacting with hydroiodic acid, the hydroxide and the hydrogen combine to form water, and then the potassium and the iodine produce potassium iodide, which is the salt. And the point at which you have reacted equal amounts of acid and base together is what's called the equivalence point. This terminology will be useful when I show you this little lab demonstration coming up. Now, there's a special laboratory procedure called a titration, and I really hate that y'all can't actually do this lab. It's one of my favorites to do because it involves using a bunch of cool lab equipment. But titration is essentially just a method of determining what the molarity is of a solution, such as an acid or a base. It doesn't have to be either of those, but in this case, we're working with acids and bases here. And what you do is you take a solution whose volume, you know, and you react it with another solution whose molarity or concentration you know until you reach the equivalence point. And there's a very simple equation that goes with this. So it looks very similar to the dilution equation. It says the molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. So if you, for instance, know the molarity of your base and how much of it you're using, and you know how much acid it takes to reach the equivalence point, well, some simple multiplying and dividing will help you calculate the molarity of the acid you're working with. And to know when you have reached the equivalence point, that's when we use indicators, which we learned about yesterday. And there's this thing called an end point in a titration, and that's the point where the indicator changes color. And you want that to happen near the equivalence point so that you know to stop. So, for instance, in a lot of acid base titrations, the indicator we use is called phenolphthalein. It very clearly goes from colorless in acidic solutions to pink in basic solutions. So, as soon as you see that color change, you know you've reached the equivalence point. You stop the titration. So, now I'm going to show you a video of a titration that I did so you can check that out. All right, for today's experiment, I'm going to explain how to do what's called a titration. And the purpose of this experiment is I've got this hydrochloric acid, and I don't know what the molarity of this acid is. So I'm going to try to figure that out using this 0.050 molarity sodium hydroxide solution. So I'm going to react a known volume of sodium hydroxide, whose molarity I know, with a volume of hydrochloric acid, whose molarity I don't know. And in order to do that, I need to keep careful track of the volumes that I use. So the first thing I'm going to do is, using this Erlenmeyer flask, I'm going to transfer exactly 10 milliliters of hydrochloric acid into the flask. And I'm going to use this device called a pipette, which it looks like a straw with a tip on the end, and it's got this little line right here. And when you fill the liquid up to the line, that is exactly 10 milliliters. I've got this thing called a pipette bulb, which I'll squeeze to initiate it. Then I'll put the pipette into the solution, and then I push the up arrow, which will draw the hydrochloric acid up into the pipette until I reach the line. And then I'll go over to the Erlenmeyer flask and press the down arrow on the pipette, which will dispense the hydrochloric acid into the flask. And a very small amount of acid may remain in the pipette, and that's perfectly fine. It's calibrated for that to happen. So I've got the hydrochloric acid in here. Then the next step is I'm going to use this device called a burette, which looks like this. It's got several different parts to it. You've got this long part is called the column, and it's numbered from 50 down here at the bottom all the way up to 0 milliliters up here at the top. And so when you fill this burette up, it keeps track of the volume that you use. It also has this little valve assembly, which is called a stopcock. It is a Teflon coated plug that has a little hole in it. And when the handle is in line with the column and the tip, then the liquid can flow through. And when you turn it perpendicular like that, the liquid stops flowing. And then this part down here is called the tip. And to use this properly, you put the burette in what's called a burette clamp, which will hold it in place. And then I'm going to use a burette funnel to fill the burette up with the stopcock closed. And I'm going to pour slowly so that I don't overfill this. And then before I can actually use the burette, I've filled it a little bit past the line, but there's no liquid down in the tip. So I need to open the stopcock, let some liquid flow through, to get the air out of the tip, and also to get the burette centered exactly at 0. And let me help you see that. The burette is right on the 0 mark. So now I'm going to use the burette to add the base to the acid. When they react, we're going to make water and sodium chloride. That's going to be the products of this reaction. But in order to know when the reaction is complete, I need something called an indicator. For that, I'm going to use this stuff called phenolphthalein, which in an acidic or neutral solution is clear or colorless. And when the solution turns basic, it turns a pink color. And so it'll let us know when we've added just the right amount of sodium hydroxide. Now to use this burette, I'm going to hold the flask with my right hand and swirl while I add the base and manipulate the stopcock with my left hand. Whichever hand you're right with is typically the one you're going to want to use for the swirling action. You can start to see a little bit of a pink color that's staying around, so I'll slow things down a little bit until the pink becomes more persistent. And there we have a very faint pink color that we're looking for. Maybe a little difficult to see. But the faint pink, well, it's actually faded. Let me add another drop. See if we can get it to stay. It needs to stay pink for at least 10 seconds. Not quite there. There we go. That is the faint pink color that we're looking for. And so now we come over to the burette and we read it. And it looks like this burette is sitting right at 30.1 roughly milliliters right there. So now we have enough information that we can calculate the molarity of the acid.